So it is after the production of energy the most polluting sector. And then we have a look at from where exactly do the emission comes. So you have, it's in French, sorry, but you have 40% coming from the digestion in the cattle, 16% coming from the manure decomposing on the meadows or on the ground, 12%, like we said before, for the production of fertilizer, 10% for the production of rice, so from the methane emission from rice fields, and then 7% from the manure management, and 5% from burning of forests and savannas. So what we can see is about 2/3 of this emission is due to animal husbandry. So the whole manure management plus the cattle themselves makes about 60% of the production. So this is the share worldwide. And then is the question, is this a big issue for Africa? Is Africa contributing a lot to this greenhouse emission of agriculture? So the answer is about yes, because we can see that Africa share for agricultural emission is about 15%, so it's quite corresponding to its population, which is 17% of the world. So it's quite a relevant share. But what we can of course say is it is also the only sector where Africa contributes a lot to greenhouse emission, because otherwise Africa contributes only to 4% of total greenhouse gas emission. So of course there are other continents that should limit the emission first. The next cause of these problems, we have the erosion of and leaching of soil. So here you have the beginning of erosion on cropland. You can see that the water is taking the soil away, which is a big problem today on everywhere in the world. And you can get areas like that where the whole soil is taken away. And this of course is a lot due to the absence of erosion measure which could limit the runoff, like hedges and grass and trees and things like that. It is a problem in Africa. Yes, as you can see, it is according to this study on what are the main risk for soils in the world, that erosion is the major threat for soils almost everywhere in the world except in Europe and Asia. We of course have other drivers of soil degradation next to erosion and leaching. For instance, loss of organic matter. This is usually due to a warm and humid climate and to an exposed and open soils. So it is also due to the absence of input of organic matter. So if you only add mineral fertilizer, you can have a soil which is depleted in organic matter and which gets poorer and poorer. So is this a problem in Africa? Yes, as you can see, it is the second main threat that this study finds, the change in organic carbon in the soil as a second threat. Then of course we have other issues like acidification, compacting, salinization. Okay, So now we discuss a bit all the issues linked to the conventional agriculture, linked to today's agriculture, and of course the question now is what we can do instead of this. So a possible solution could be agroecology. So agroecology can be defined as a scientific field, an agricultural practice, and a social movement. It is an innovative approach to the sustainable and rational use of agriculture and water resources. On this lecture, we will mostly talk about agroecology as a science and agricultural practice, and not much about the social movement aspect. And in this part, agroecology allows the production of healthy and high nutritional quality commodities free of pesticide and uh, products from synthetic chemistry. The approach of agroecology aims to produce, regenerate soils and degraded environments as well as promote biodiversity. So on this scheme you can see a ladder on how to um, transform a system in an agroecological system, so how to integrate agroecology in your system from level 0 to level 5 and adding different aspects of the system. So on the first level we try to increase efficiency of industrial input. So we still rely on fertilizer and pesticide, but we will try to improve the efficiency. So we will use fertilizer, for example, at the right moment, at the right amount, in a combination with organic input, for example, to maximize the efficiency of the both fertilizer. And in the case of pesticide, for example, we would monitor quite well the situation of our pest and disease and spray the product where when it's needed, where it's needed, and at the right amount, and try to be um, not to yeah, like it's an integrated production. And in the second level, we will try to substitute some of these products and practices. Um, For example, using recycling, we will be able to produce manure from animals or from compost, and we can substitute a part or the whole of our fertilizer need. We can also recycle some of the production to produce biopesticide, for example, use uh, garlic or ginger to make mixture to repel some pests. And then on the third level, we design the whole system and we really think our farm is an agroecosystem and how can we manage, so a bit what we do with our agroecological farm. And in this case, we will add a high diversity because biodiversity is essential um, for an agroecological system. We will make as much synergies as possible between the different parts of the system, between the animals, between the plants, and so on, and we will have a resilient system with diversity and synergies that we will allow to react better to problems like climatic issues or pest issues. And then we have the fourth and fifth level, which are more uh, which have more to do with the um, social movement of agroecology, which we will not discuss in this lecture. So concretely, what does it mean? It means, first of all, we will integrate the different parts of the system. So we will integrate animals, plants, we will integrate trees, annual crops, and so on, to have the most resilient and producing system. We will make crop rotation, so we will never leave the same crops on the same um, plot every year. We will make crop associations, so always try to cultivate more than one crop on one field. These two or three even parts are really important for the global biodiversity of the system. We will use water efficiently, so we will introduce measures to limit the loss of water, and we will protect the soil by limiting the impact we have on it, to limit erosion, to limit loss of soil organic matter. So here you have an example of a field a bit extreme that we installed on our farm in Cameroon. So maybe it looks a bit like forest, but it's actually a field. Everything that you can see can be eaten. So you have um, squash creeping on the ground. You have yam climbing, and then you have banana and papaya. So you have such high soil cover with all these different crops that you have a really well protected soil, so nothing can be washed away or leached. And in addition to that, you have a high biodiversity with different crops, a lot of refuges for beneficial insects, or spiders and other insects can live on this plot and can then fight the pest that could um, come. And then so you see here the same crop from the sky. So in comparison to the plot left of it, which is burned, you can see that the soil is really well protected and that we have a high biodiversity on this plot. So you can see also this is pigeon pea, the bushes, so I forgot to mention it earlier. Here you have a association of vegetable, for example here onion with carrot. So this association that we practice in all of our farms is quite interesting. So both have a similar growth rate, size, and then the carrot will repel the pest of onion, and the onion repels the pest of carrots. So here, yeah, that was a few example of agroecological practices on our different farms. So agroecology has a high potential, mostly for small-scale food production, because it can be interesting for small-scale farmers independently of the environment and health issue, because it implies a low cost of inputs, because you don't have pesticide, fertilizer, even seeds to buy. It can be interesting because uh, has it creates an income diversification, so you have a highly diverse farm with different vegetables and fruits, so you have a lot of different products that you can sell, which can be interesting for small scale farmer, because he can then easily sell the different crops, and if one crop fails, he has the other to save. It could be more complicated for a big farmer to sell so much different commodities. Um, it's interesting for him to preserve his soil. Often small scale farmers are more interested in protecting the soil because it's their land and they don't have much of it. It's also interesting because it gives a better resilience to climate hazards, which is quite important in today's context of global warming, and the impact on health of the absence of pesticide and fertilizer can be interesting for this small scale farmer, because his land is mostly just next to his house where he lives. But there are also some constraints. First, it is complicated, so some of the practices are easy to applicate and are easy to understand why we should do them, but others can be more difficult. And if you have really a highly integrated agroecological system, it implies a good understanding of the system. It can be difficult to sell the diverse offer, and it needs a lot of workload to do this kind of agriculture, because you don't rely on herbicides and not much on machines. The yields can be lower than in conventional farming, but not necessarily. And in certain crops that have a really have pest problem, it can be complicated. For example, tomatoes can sometimes be difficult to do without any pesticide. So, in conclusion, agroecology is particularly suitable for small-scale food production because it's perfect for small area, for an abundant labor force, which is often the case in the small-scale farmer when there are a lot of family and villages, and the crop diversity is beneficial to the farmer. It has the potential to improve the standard of living of this farmer, especially those in difficulty, those that have infertile soil, irregular, insufficient water, and few resources to buy agricultural inputs. And of course, this type of production is less adapted to cash crop farming, where farmers often specialize on one particular crop. So now I'm finished with the global introduction on for this lecture, and we'll talk about the practical aspect of the lecture. So this lecture is made for agronomy students with good background in soil science and conventional agriculture. It will cover some of the basics that you probably know about ecology, chemistry, agronomy. Just a reminder, in order to understand well the different agricultural practices that we will talk about. And mostly this course will talk about the different practice, the different agroecological practice, why they are used and how. So we will deal with the following aspects: the management of soil fertility, the management of pest and disease without pesticide and without pesticide. So mostly biodiversity, crop rotation, crop association, and biopesticides. We will talk about how to integrate and how to use the animals in the agroecological
So
system.
after this course, the student will be able to understand the functioning, advantages, and disadvantages of an agroecological production system, as well as identify the differences with conventional systems. So this course will alternate pre-recorded presentation like this one with multiple choice question exams after every week. So weekly, you will have then to read the chapter in handouts before class. It's better if you can read it before. And then after class, you will have 1 week to do the MCQ, so the multiple choice question. So regarding the program, you can also access it in the Google form, the one you have used to register to this online course. So today you had the first lecture on Introduction to Agroecology and Challenges of Conventional Agriculture. And then you will go along the program, so biological and pest and disease control, crop association, agroforestry, soil protection, water management, method techniques, crop association in practice, so a second course on crop association, a bit more practical, seeds collection and animal husbandry, fertilization, and an agroecological farm. Then you will have the final exam. So it's also an MCQ with open questions. Yes, and so you will have the final test on the 21st of February, and then weekly, as I mentioned just before, then videos and MCQ tests.
In case you want to read more related to this theme, so you will have the script, a complete document related to this lecture. You will also receive the slides of the of the lecture. And in addition, I recommend, of course, the Soil Science book from Scheffer Schafzabel and also the agroecology book from Martin and Sauerborn. So here the reference for about the studies that I mentioned today. And I thank you for your attention, and you can transmit your question um, to the channel which will be organized. Thanks a lot for the attention, and I'm looking forward to meet you in 2 weeks' time. Bye. Thank you.